Good evening / morning grade 9s. We're going to look at some of the common points of improvement based on 2017's test. And for question 1, it's mainly around the order of the letters. So if we look here on the left-hand triangle, we're starting with letter A. If you can view the triangle and think, how did we get from the left-hand triangle to the right-hand triangle, and see, oh, we've rotated and reflected, that's great. But if not, we can say, well, A is sitting over here, and it's sitting between the sides that are 2 and 4. So which letter on the right hand triangle is between 2 and 4? Well, it's clearly this angle at E. So we've got E first up, and then let's do the same trick for B, because B is next up here. So B is this angle here, and it's sitting between these sides 3 and 4. So what's sitting between 3 and 4? Well, this one here, so it must be D. And finally, we've got, well, obviously it's going to be C matches up with F, but let's just do it anyway. We've got C over here between 2 and 3. So between 2 and 3, we've got angle F. And obviously this one, we've got 3 sides. So side, side, side. So that's one way of doing it, and it works because it's a scalene triangle. In other words, all the lengths are different. So that little trick works quite well. For question B, we're going to do a similar type thing. We've got 50 degrees sitting at G between 6 and 7, and in this triangle we've got 50 degrees sitting between 6 and 7 at M, so G matches up with M, and that's going to be in the middle. And if we go from G and go 7 units, then we get to H. So if we go from M and go 7 units, we get to N. So H and N match up. Clearly our last letter should sort itself out, but let's just check it to make sure. We've gone G 6 units to get to K. We've gone M 6 units to get to L. So L sits here. And if we can see, this triangle on the left has just been rotated anti-clockwise to get to this triangle on the right. And this is side angle side. We're going to skip over question C as well as question 2 because most of you are getting this right. For this question here of justifying your answer, I'm not going to go through in detail, but basically you need to say that in all squares we've got 90 degrees in all the corners, and in all squares all the side lengths are the same. In some form like that. Have a look at the memo. We're not going to spend time on that one. For question 3, most of you are getting it right. We're just going to focus on the layout as well as the reason so we get that right. So we've got these two triangles in triangle ABC and triangle DEC. The order of the letters doesn't matter at the top here. We're going to say 3 things, and then we're going to sum up by saying, therefore, one triangle is similar to the other triangle, and there the order of the letters does matter. So let's look at what we got. We've got this angle at A is equal to this angle at D. So we've got A angle equals D angle. But we need to specify which D, because we've got these 2 angles sitting at D. So let's say it's this one that's going CDE is the one we're looking at. So CDE. And what's our reason there? Well, we've got these parallel lines. Funky, this one is corresponding. That's an awful picture there, isn't it? But I think you get the idea, right? It's the F. We've got corresponding, but it's not enough to say corresponding angles equal. We need to say something about parallel lines. Well, in this case, AB is parallel to DE. Similarly, angle B is angle equal to angle E. So B is equal to E. We need to say which angle at E. This one here, so CED and CED. And again, we have to say corresponding angles equal AB parallel to DE. And finally, we've got our last angle to do, which is angle C. And you can either say C equals C, or you can say angle C is common. In other words, it's the same angle, and the reason really is given, or you can say common, doesn't really matter. And let's sum it up. Let's write down our first one, ABC. Well, we already said that A is equal to D, B is equal to E, and C is the same C. So there we go. Let's give a reason for why that is the case. Angle, angle, angle. For question B, we're trying to find the length of BE, this side over here. And just so we can picture it, especially because our diagram's looking a little messy now, let's redraw our two triangles. We've got triangle A, B, C, and we've got the other triangle which is similar, and that is triangle D, E, C. And fill in the bits we know. We know AC is 7 because it's 5 and 2. We know DC is 2. We know this is 3. And that's pretty much all the information we have at this stage. If we can work out this full length BC and subtract this 3, we'll get BE. So BC, because these two triangles are similar, the sides are in proportion. In other words, CB, this side here, divided by CE is the same as AC divided by DC. In other words, if you take the big triangle and divide it by the small triangle, it's in the same ratio. But we've got some of these things. CB, we don't know what it is. CE, we know is 3, and we know that AC is 7, and we know that DC is 2. Let's multiply both sides of this equation by 3 on the left-hand side, which, I don't know why I'm writing it down here, you should write it underneath each other. We've got CB equals 7 over 2 times 3, which is 10.5. Ooh, that's a 10. Therefore, if we subtract the 3 over here, then we'll get the length of BE, which we want, which is 7.5. Done. For question 4, I'm going to go through a bit slower in terms of how do we prove these two triangles are congruent, because there were a few assumptions along the way that I'm not quite happy with. So we asked about these two triangles here. This triangle is congruent to this triangle here. And first off, it looks like it's just been reflected, and that is going to turn out to be the case. We've got a right angle, and that's all that it looks like we've got to start with. So in terms of our 4 options, it could be side, 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 could be side, angle, side, could be angle, angle, side, and it could be right angle, hypotenuse, side. Yes, we can't have that other naughty one. Notice that in all of these, we're going to have to find a side somewhere along the way. So at least one side we're going to have to find out, and we're not given any, there's no triangle that says that side equals that side. There's hatch marks, so there's not going to be a given as any of our reasons for that. But let's start with what we got. In triangle, and our first one, DBF, the one on the left, and triangle ECF, remember order doesn't matter in this for this first bit. We're going to show 3 things, and then we're going to sum up to say, therefore triangle something or other is congruent to the other triangle, and we're going to give a reason, which we don't know what it is yet. So let's start with the obvious one, because there's one obvious thing here. That's this right angle and this right angle. We know that angle D, and we're going to have to say which angle at D. So that D is equal to E, well, let's say BDF is equal to CEF. What's our reason? Well, that much is given. And in fact, we can say it equals 90 degrees. So it looks like maybe we're looking right angle hypotenuse side. Hint, we're not going to go that route. Now, I would suggest that if you see an X, like over here, vertically opposite angles are something that often come up here. So we can see it here that if you've got a case like that, those two angles are equal. So we've got that angle around F. Now it's not good enough to say F equals F. Which F are you talking about? Well, we've got BFD, and on the other side we've got CFE. CFE, what's our reason? It's not given. It doesn't say that those two are equal. We're using the fact that they're vertically opposite angles. And let's think back to our 4 reasons on the right hand side here. At the beginning I said every single one of those has a side, so we're going to have to find a side that is equal to another side. We're definitely not going right angle hypotenuse side because that requires two sides, and so far we've got two angles. So it looks like if we've got two angles, it might be angle side. So let's go through, and I'm going to go through the sides that we cannot say are equal. Let's start with this side here at DB and EC. There's no reason we can say those two are equal. There are no hatch marks like over here. There's nothing that can tell us those two are equal. DF and EF. Again, there's nothing there. If this top shape if we're told that it's a kite, then we could say maybe that they're equal, but there's nothing telling us that. So let's go to our last side to say this side here, BF, let's see if we can show that it's equal to CF. And I'm going to complete the triangle here and go, oh, well, we're given that angle, this angle at B and this angle at C are equal. In other words, we've got this special triangle, isosceles triangle. What do we know about isosceles triangles? Base angles are equal, and I've got two sides that are equal. And let's use that property. Because these base angles at B and C are equal, therefore we can say that BF is equal to CF. So that's what we're going to say. We're going to go BF is equal to CF. How do we know that? Because it's an isosceles triangle. Which triangle are we talking about? We're talking about the triangle BFC. So we're saying this triangle here is an isosceles, and we're given the base angles are equal, therefore the sides are equal. So we've shown angle, side. So we can fill this part in already and say our reason is going to be angle, side. Let's put our first triangle in as they've given it to us, DBF, and see if we can match it up with the letters on the right hand side. Well, D was the right angle, so that must match up with E. F was the same we showed, so F must match up with F, and we're left with B is going to be equal to this angle here at C. And that seems to fit in with what makes sense looking at the diagram. And now on B they ask us, hence prove that ABC, triangle ABC is isosceles. With this word hence, it normally means we're going to use something that we've just proven before that. So we've proven that these two are congruent, so we're probably going to use that. Isosceles triangle, two ways to prove it, as we can see from this triangle here. Either that the base angles are the same, or that two sides are the same length. Well, we've got this big triangle here. We know now that DB equals EF, but we still don't know anything about AD and AE. We haven't shown anything about those sides. We still don't know if they're equal. So we're going to have to say, can we show that this angle here is equal to this angle? In other words, the big angle at B and the big angle at C, are they equal to each other? Well, we already know that this angle and this angle are equal because that's given. So can we show that this angle here is equal to this angle here? Well, we know they're equal because the triangles are congruent. So how do we write that? Because I think quite a few of you were kind of there and getting there. So we can say that angle DBF is equal to angle ECF. In other words, the ones that we've just shown in red up here, they're equal to each other. How do we know that they're equal? Well, it's because these two triangles are congruent. So we have to write that. We say, how do we know that? Because DBF is congruent to triangle ECF. Well, if this angle here is equal to this angle, and this angle is equal to this angle, which was already given, then we can say that angle DBC, this whole angle here, angle is equal to this whole angle here at C. So the one at C, which is BC A, probably would have been better to write instead of D. Let's write this one as A, because then it relates to the triangle. Well, if those two are equal, then it's an isosceles triangle. How do we know it's isosceles? Because these base angles are equal. Okay, so I'll ask you. Let's go through it and cruise through this. Question A for, what are we on? Question 5, multiple guess. Well, angle, that's nonsense for congruency. Congruency, the triangles have to be the same, and angle doesn't necessarily tell us that, because that triangle and that triangle might have the same angles, but as we can clearly see from my lovely drawing, not to scale, they're not the same with angles, so they're not congruent. Okay, so that's question A, easy, 2 marks in the back. Question B, we've got these two triangles here, and what's the value of x? We're in a test about congruency and similarity, so let's see if we can use that. Are these two triangles, by these two triangles I mean that triangle there and this triangle here, well, it's either going to be congruent or similar. We don't need to go through the whole process of is it congruent, in triangle this and triangle that. We just need to see, well, we've got these parallel lines, so they're going to come in handy, and what they're going to tell us is that that angle equals that angle, this angle equals this angle, and vertically opposite angles are equal, so that angle equals that angle. Hopefully you can see that we've taken the red triangle and rotated it round by 180 degrees to get the blue triangle. We've got a 12 sitting over here and a 10 sitting here, so the two triangles are similar. In other words, if you've got your red triangle, you've got 12, 9, and 10. And if we look at our blue triangle and we rotate it round, then we rotate it such that x is over there and the 10 is now sitting over here. So the 10 and the 12 go together, and the x and the 9 go together. So if we go x over 9, this smaller triangle over the bigger triangle is the same as 10 over 12. Well, let's do like we did in one of the previous questions. Multiply by 9. Therefore, x equals, now you can do some nice cross-cancelling here. You can say 3 goes in there 3 times, 3 goes in there 4 times, 2 goes in here twice, 2 goes in here 5 times. Therefore, 15 over 2, well, that equals 7. Well, let's make this nice, equals 7.5. Or you could have just said 10 over 12 times 3 on your calculator, and I got 7.5. And yay, that's one of the answers. And now that we've got all this energy still, let's just write on the left here. We've got our kite, and I'm just going to highlight where congruent triangles are, because you pretty much see it or you don't see it. There's one triangle is congruent to that one over there. Now we've got another triangle over here, and it's congruent to that one. And finally, you've got this triangle here is congruent to that triangle. So there are 3 of them. Yes, we could go through it and say this one's because of side, side angle, side. You could go through that laborious process, but really just see if you can count them up. And we reach our last question, because we did question 6 in class together. And we've got our 2 triangles here. We're told that they're similar. And it looks like an issue because we've got a 20 over here, but we don't have any number over here. And we ask for the perimeter of the larger triangle, which is the one on the right, this one here. Well, right angle triangle, our dear old friend Pythagoras comes into play. It's just multiple guess, so you don't have to show you're working, but write down you're working on the right or somewhere on the page so I can see it at least. And let's see it, 3, 4, hopefully we can recognize that this is a 3, 4, 5 triangle. Pythagorean triple, therefore if this is 5 and this is 20, we've multiplied this by 4 to get the right angle triangle. So 3 times 4 means that this side is 12, 4 times 4 gives us 16. So we've jumped quite quickly through that, but we're saying that the triangle on the right, each side is 4 times as big as the one on the left. And we've got 12, 16, and 20. With a bit of luck, we add that up and we get 48. Is it 48? Yeah, it is 48.